The purpose of this video is to teach you the basics of carbon and its effects on climate change in 5 minutes or less. Let's get the ground rules out of the way first. Number 1, we're all in agreement here that climate change is real and it's a problem that needs our attention. Number 2, climate change is a complicated issue and one that would be impossible to cover in a 5-minute time span. With that said, it would be worth looking at carbon's role in the process as it's one of the major driving factors. Let's start with a review of basic chemistry. Carbon is an element. It's number 6. You'll find it on the periodic table. Along with hydrogen, oxygen, and nitrogen, it's one of the most abundant elements in the Earth's surface. At room temperature, carbon is a solid. You might recognize it as graphite, or in some more elaborate configurations, a diamond. Now, this oversimplification is sure to annoy some chemistry majors in the audience, but there's a common reaction, which is that if you take a molecule of oxygen, and you combine it with some compound containing carbon, then the reaction produces energy in some usable form, and in addition, giving off carbon dioxide. We see this kind of reaction happen all the time in nature. For example, if you light something on fire, oxygen in the air binds with carbon from the fuel source, and this gives off heat and light, but also produces smoke. Animals, too, produce a similar reaction in their body. They breathe in oxygen, bind it with some carbon within their bodies. This produces the energy required to sustain life, but also gives off carbon dioxide, which must be breathed out. On the other hand, here's a slide to annoy the biology majors. Photosynthesis, greatly simplified, is a process which takes a carbon dioxide molecule, combines it with an energy source, such as light from the sun. In this way, the plant produces a carbon-containing compound, such as a leaf, or sugar, or bark, and it also gives off that free oxygen molecule. The other important thing we need to know about carbon dioxide is that it acts as a greenhouse gas. This means that just like a warm blanket, it traps heat against the Earth's surface, instead of releasing it out into space, and that causes the planet to get warmer. More carbon dioxide in the atmosphere is like a thicker blanket, holding more heat against the surface. Throughout much of human history, carbon in the atmosphere has remained in a sort of equilibrium. Forests and plants would grow, pulling carbon dioxide from the atmosphere down into a solid form. As needed, humans would cut down the trees, burn them, and this would release the carbon dioxide back into the atmosphere again. This makes a lot of sense when you think about it from a carbon perspective. A tree is basically a giant cylinder of carbon. As the tree grows, carbon continually accumulates within the body of the plant, and once it reaches a mature size, the carbon is retained in solid form and is thus kept out of the Earth's atmosphere. Then in the 1700s and 1800s, the Industrial Revolution occurred, and humans suddenly found themselves with a much greater need for energy. While you can power a steam engine or a factory on wood, it's hard to power thousands of them. And wood brings its own problems with a slow growth rate and other environmental factors. The solution to this problem came in the form of hydrocarbons. A hydrocarbon is a particular arrangement of hydrogen and carbon atoms. Common examples might be coal, natural gas, or oil. Hydrocarbons are great because they pack a lot of energy into a small volume. All the good hydrocarbons were locked away underground for millions of years, though. And so, humans started digging them up. And we dug up lots and lots and lots of them. For 200 years, we've dug up billions of tons of them. But of course, nothing's free. If you remember that reaction that we looked at before, burning hydrocarbons releases that long-lost carbon up into the atmosphere, where it becomes a greenhouse gas. We only need to look at our modern cities, or our modern highways, and suddenly a graph like this one doesn't seem so far-fetched. All that carbon had to go somewhere. So what can we do about this? Well, just like balancing a budget, we've got to take a multi-step approach. First, we can reduce our overall energy usage by choosing more energy-efficient options in products and services. Lower energy demand means lower hydrocarbon usage to fulfill that demand. Next, we need to change our methods of energy production to something that isn't dependent on hydrocarbons and carbon emissions. Nuclear, hydroelectric, solar, wind, and other so-called renewable energy sources are great candidates for replacing fossil fuel-burning power plants, but they still have a long way to go. That said, we can't simply cut our way out of this problem. There's too much carbon in the atmosphere and it needs to come down. There's a few ways to remove carbon from the atmosphere. The oceans act as a giant carbon sink. They pull carbon dioxide from the atmosphere and store it away. But again, nothing is free. This storage of carbon into the oceans has a separate side effect called ocean acidification, which is really disastrous for coral reefs and shellfish, although jellyfish seem to like it quite a bit. Scientists are also looking at other methods to capture and contain existing carbon from the atmosphere. One solution involves capturing carbon and storing it into abandoned oil wells or underground caverns. Ironically, oil companies are already doing this as a way to increase pressure within the oil well and boost production. But all these technological solutions seem like a lot of work. If only there was some natural process which would filter carbon from the atmosphere and store it away in solid form. Oh wait, there is. If you allow a tree to grow for 20 years, then chop it down and burn it, then you've at least taken some carbon out of the atmosphere for the duration of that tree's life. And if burning wood is a substitute for digging up new hydrocarbons from the ground, then maybe that's not such a bad proposition. But there are other ways to use wood than just burning it. If you cut it up into lumber and build a house out of it, then that carbon is held out of the atmosphere not just for the life of the tree, but for the life of the structure as well. And letting a tree rot doesn't necessarily turn it back into 100% carbon dioxide either. Some portions of the tree aren't able to be biodegraded and remain in the soil. After all, where do you think all those hydrocarbons came from in the first place? There are even more exotic solutions to the problem of carbon dioxide in the atmosphere. For example, there is a proposal to launch excess carbon dioxide into space as a means to dispose of it. In any case, it should be apparent that the magnitude of this problem is so great that it's not going to be solved by individuals or groups alone. Humanity really needs the buy-in from governments and major corporations to make this thing work. Only they have the power to regulate carbon emissions or to build cleaner production facilities for alternative power.